Good evening everyone. Myself Aditi. I am from GM University and today I will be presenting my operating systems mini project on hybrid CPU scheduling, innovate and purpose. The contents will be introduction, experimental setup, implementation setup, output, observations, comparative evaluation, conclusion and overall analysis. So moving on to the introduction part. Introduction to CPU scheduling. The operating system manages CPU execution among multiple strong processes, but choosing which process gets the CPU first requires efficient scheduling algorithms. Each algorithm has advantages and disadvantages. Priority scheduling urgent tasks first but causes starvation. Then when we choose the SJF, shortest job first, it reduces the waiting time but ignores the urgency. Then comes the SRTF. It has a great response time but high context switching. To overcome these issues, I have designed a hybrid scheduler that combines priority plus SJF or SRTF depending on the user's choice. The next is the problem statement, which in my goal is being said. The goal was to set develop a scheduler that minimizes the waiting time and turnaround time, which also reduces the starvation and which supports both the primitive and non-preemptive execution, which allows dynamic user inputs and displays detailed output with Gantt chart. The project features, which is done by C program, includes input support for arrival time, burst time, and priority. Option to choose scheduling types, which is non-preemptive hybrid, preemptive hybrid. The non-preemptive hybrid means priority plus SJF. Preemptive hybrid means priority plus SRTF. The continuous updates of waiting time, turnaround time, completion time, and response time. It also gives the graphical Gantt chart. The Gantt chart will be given in the text form, structured form, or compact form. And it also helps in messages for the user confusion. Like if the user gets confused somewhere, it will give you a message how to do it properly, validated with multiple datasets. Then here comes the flowchart explanation. As you can see, we can start the project. First, we will give the input processes and scheduling mode. Sort out by the arrival time. At every scheduling decision, we choose the highest priority. And if the highest priority is a tie, we will take the shortest job first, that is SJF. The execution is based on preemptive or non-preemptive rules. Updated calculations and generating Gantt chart is also there. Display of the final results will be given in the end. Then the experimental setup. I have coded and executed the system in GCC C compiler and GDC compiler also. Multiple datasets were tested to evaluate performances. We have also taken multiple C program and we have also written multiple C codes which were given errors. But then in the end we have taken one such perform which will include waiting time, turnaround time, completion time, response time, and even the context switch count. So it is possible to do everything. Then here comes the observation part where we can literally see from testing we observed hybrid scheduling. Yes. From testing, we can say that we observed hybrid scheduling outperforms individual algorithms. Preemptive mode gives better response and fairness. Non-preemptive mode has fewer context switches. Starvation fully eliminated due to secondary SJF SRTF selection. Then we will also show the table and small explanation beside the table, and then the comparative evaluation. As shown in the comparison table, average waiting time decreased, turnaround time has also been improved, efficiency has increased for both small and large datasets, priority fairness has been maintained, interactive tasks handled smoothly, and then comes the output which we got from the code. Here you can see in the output, it prints the Gantt chart, timeline values, and outage matrices, that is turnaround time, waiting time, completion time, and response time. This verifies that the scheduling order is correct. And here in the screenshot you can see First, it will ask the number of processes. You can give how much ever as you want, and it will ask you the arrival time, burst time, and the priority of the processes you have given. After giving that, it will also ask you a choice for asking whether you want a preemptive or non-preemptive. Preemptive hybrid means priority plus SJF, and non-preemptive means priority plus SRTF. And then starting it will start the execution, and there you can see the outputs, the context switches, how many times it has been happened in the first one and the second one. The Gantt chart will also be given in structured form and within the compact form also. And then when given an invalid input, as in given in a float number, it will ask you to give invalid input, please give a proper integer. After giving that, it will start executing properly. And then within the conclusion, we can say the hybrid scheduling algorithm gives the best performance balance, better responsiveness, reduced average waiting and turnaround time, no starvation, suitable for real-time and general purpose systems. Thus, we can say that hybrid scheduling improves overall CPU utilization and fairness compared to the traditional priority and SJF or SRTF scheduling individually. Thank you for listening to my presentation. I will be happy to answer any questions. Thank you.